Hello dear viewers, welcome to my tutorial video. In this session, I am going to show you how you can develop a WinCC SCADA system with server-client architecture. For your better understanding of SCADA system with server-client architecture, we will proceed to make a simple WinCC SCADA project with server-client architecture. When we will come to finish this project, we will perform start and stop operation of a DC motor using an S7-1200 PLC, where the motor operation and status monitoring will be performed from multiple WinCC SCADA interface that have been configured in server-client architecture.
For large industries, it becomes necessary to operate the plant from several operator stations by different operators, or often data from different systems have to be collected and evaluated centrally. The use of a WinCC client-server system is recommended for this purpose. The WinCC server handles communication via the process bus with the system controllers and provides the user data and visualization data for the WinCC clients. This makes the system to be operated simultaneously from several operator stations by different process operators.
In this video, we are going to develop a WinCC SCADA system where combination of a server station, a client station, and an engineering station have been used in a network to get multi-user type operator interface. An S7-1200 PLC have been used in the same network to control a DC motor. The PLC program and SCADA program with server-client configuration will be done on engineering station. Then the PLC program will be downloaded to PLC, and SCADA program will be transferred to server station or server PC. When the SCADA program will be run on the server station, the server will communicate with the PLC to collect the motor operation data that will be available to the client station, and then it will be possible to perform motor start-stop operation from the client station. Though in practice, the motor operation and monitoring is done from client station, it will be also possible to perform motor operation from engineering station and server station.
Before to proceed to this project, we can take a look at the step-by-step procedure that we can follow to implement this project. This will help you to get clear idea about the whole task of server-client configuration, which will be easier to complete the task. First of all, make proper configuration for each of the 3 PCs so that these PCs are turned into one PC for engineering station, one PC for server station, and the third one is client station. In the next step, make proper communication setting for engineering PC, server PC, and client PC. This will establish the network connectivity for these PCs so that data exchange takes place frequently among the PLC, server station, and client, or operator station.
When we will come to finish the configuration and communication settings for engineering PC, server PC, and client PC, make a simple PLC ladder program and a SCADA program on the engineering PC using TIA Portal software. After successful compilation, the ladder program will be transferred to the PLC and the SCADA program will be transferred to server PC. Finally, run the SCADA project on the server station and perform the motor start-stop operation from the client station, server station, and the engineering station. Now let's proceed to make configuration for PCs or WinCC stations we have taken for this project. This configuration includes a number of settings that must be done for successful server-client operation, and these settings already done in this project. The first setting is that all the WinCC stations that have been connected in a network must have a PC name, and they must be logged into under the same work group or the same domain.
To take a look at these settings, go for the PC that has been configured as engineering station. Open the window for PC settings.
Note that a specific name has been given for this PC station.
To get details of this PC,
go to System Properties dialog box, where you will find that the name of this PC station has been registered as a member of Workgroup. If you want to change the PC name and workgroup or domain, go to dialog box for Computer Name.
From this dialog box, you can change the PC name and select the desired workgroup or domain. For this project, PC name has been registered as member of workgroup.
Go for one of the two other PC station that has been configured as server station. Go to System Properties dialog box.
The name of this PC station has been given as server, and it has been registered as member of same workgroup which has been also found for engineering station.
Go for another one PC which has been configured as client station. If you go System Properties dialog box, you will find that, like the engineering or server station, same workgroup has been selected for the client PC.
Another issue for server-client configuration is all the PC stations must be logged in using the same username and same password, and all the users of all the PC stations must be added as a member of Somatic HMI group in respective PC windows. These configurations has been already done. Let us see how these configurations have been done for all the PC stations.
Take a look at the PC for Engineering station. To get the details about the login ID and its associated Windows group, go to Dialog box for User Accounts.
Dialog box for user accounts has been opened. Click on the Advanced tab.
Using the Advanced button, open the window for Local User and Group.
Click on the User menu. On the right side, you will get the list of users for this computer. But we will use the user ID ICED with a password to log in this PC. So when you will log in the server PC and client PC, you have to use user account with the same login ID and same password.
Now go to Properties window for this user account. Note that this user account has been registered as a member of Somatic HMI group. If this account is not registered to Somatic HMI, then go to Dialog box for Select Group. Click on the Find Now button to get the list of all Windows group. On the bottom side, you will find a list of Windows group from which you can select Somatic HMI group. As Somatic HMI group is already assigned to user of this PC station, skip selection of Windows group and return to window for local user and group. For the server PC station, go to Window for Local User and Group to see the settings for user account and Windows group. This PC has also same user account with same password that has been created for login to this PC.
If you open the window for User Account Properties, you will find this user account also has been added to Somatic HMI Group, which is very similar for user account of Engineering PC.
The same user account with same password has been created for the client station, and this account has been registered as member of same Windows group Somatic HMI that we have found from Account Properties window. One more setting for server-client configuration is to enable a number of Windows services. This should be done for all PC stations. On Engineering PC, go for Windows Run command and type Services in the search box.
We have come to the window for services. On the right side of this window, you will find a list of Windows services. From this list, navigate and enable the required services that have been shown in the video screen. Navigate to one of the required Windows services, Function Discovery Provider Host, and open the property box for this service. Check that whether this service is presently running or not. This service is running at this moment. If this service is found to be in stopped condition, start this service from the Start button. Set the startup type as Automatic, found from the drop-down menu. In the same way, navigate to other required services and start these services if they are in stopped condition. Similarly, enable these services for the engineering station and client station.
For server-client configuration, one more important task is activating network discovery and folder sharing options for the PC stations. This will enable server station share process data with all the client stations. Go for the PC for engineering station. Using the control panel, go to the window for advanced network sharing settings. We are now on the window for Advanced Network Sharing Settings. Note, the Network Discovery and File Printer Sharing options for both private and public network profile are turned on. For all networks, turn on the option for Public Folder Sharing. The file sharing connection should be 128-bit encrypted. Not only for the engineering PC, Network Discovery and Folder Sharing option must be enabled for server and client PC station.
Now, for proper communication, we have to adjust the network settings properties for the PC stations connected in the server-client network. Note these PC stations have been physically connected to a network switch, which have formed a single local area network. For communication with each other in this physical network, we have to adjust the individual PC IP address and subnet mask from the respective PC network setting properties window. This adjustment will make a same physical and logical network for these PC stations. Take a look at the IP address for the PC stations. I have chosen the IP address for engineering PC 192.168.0.4, for server PC 192.168.0.2, and for client PC 192.168.0.3. Note that network ID for each PC stations is 192.168.0, which means that these PC stations are in the same logical network. Go to the PC for engineering station. From the control panel, go to Window for Internet Protocol version properties of this PC. From this window, you have to provide the IP address and subnet mask which have been provided earlier for this PC. Similarly, come to Window for IPv4 settings for other PC station, server, and client. The server and client PC stations have also come with the settings for IP address and subnet mask that have been already done. Depending on the type of IP address, the subnet mask has been provided as 255.255.255.0, which is same for all the PC stations.
Now, to ensure the correct network configuration, use ping command from the command prompt window of each PC station. Come to the PC for engineering station. Using Windows search option, go to Window for command prompt. We have come to the window for command prompt in the engineering PC. To check network connectivity with server or client PC, first type ping command with the server PC IP address and press the button for Enter. Now test the connectivity with Client PC. Note the server and client PC are reachable from the engineering PC. Similar test must be done from command prompt window for the server PC and the client PC. But to shorten the video length, I have not shown the ping test for the PC for server and client.
Next, we have to check another issue, whether the PC stations involved in the network are displayed to each other in the Windows Network window. As the main WinCC project file runs from the server PC station, the server PC name and its project file must be accessible from the network window of Client and Engineering PC. Go to PC for Engineering Station. Open Windows Explorer. On the left, navigate to Network menu and click to open the window for Network. Note the name of the PCs connected in the network have been appeared in the network window. If the PC names are not found, you have to check the issues for network configuration and ensure the name of the all PCs must be displayed in this network window. Also, you have to ensure that the shared folder and file of the displayed PC in this window must be accessible. As we are now on the engineering PC, make sure the shared file and folder of server PC will be accessible from this PC. Click on the name of server PC. Note we are able to access the files and folder of server PC from engineering PC. Now let's check whether the server PC is available from the client PC. Go to Window for Network in the client PC. The name of the PCs in the network has been displayed in the network window. If the PCs are not displayed, check necessary issue and make sure these PCs are available in this window. Click on the name of Server PC. Note that the shared folder and file of Server PC are also accessible from the Client PC.
The required configuration for all PC stations has been almost done. Also, we have done proper communication settings for the PC stations and performed a number of tests whether the PC stations are able to communicate with each other in the network. Now we can proceed to create Siemens TIA portal project for operating a DC motor from multiple PC stations. This moment we are now on the Windows of Engineering PC, where TIA portal software is installed. Let's go to the Software for TIA Portal version 16 and double-click to open this software. Now, on the left side, click on the button for Create New Project. Type a name of this project in the field for project name and click on the button for Create. In this step, a project has been opened successfully. Click on the menu for Configure a device. Open the interface for Add New Device. On the left side, click on the Device menu for Controller and select the controller S7-1200 CPU1214C AC-DC Relay from the controller list. Select the desired part no and version of this controller that have been used in this project. Finally, click on the Add button to add the selected PLC in this project.
We are ready to create a ladder program now. Go for Program window and create a simple motor start-stop ladder program. This is the ladder program for simply start and stop the DC motor. When the motor will be started using the start switch of SCADA interface, timer will count time up to 10 seconds, and then it will stop the motor using the normally closed contact M10.2. To show motor runtime in the SCADA interface, memory address MD20 has been used for storing update time value. The memory address M10.0 and M10.1 have been used for virtual start and stop switch of SCADA interface, and for DC motor physical output address, Q0.0 has been used in the ladder program. Now, compile and proceed to download this ladder program to the PLC.
We have come to finish the step for PLC ladder creation and downloading this to PLC. In the next step, we will add SCADA PC stations for engineering, server, and the client in this project. From the project tree, navigate to Add New Device and double-click on it. The window for Add New Device has been opened. Click on the menu for PC System to get the list of PC stations on the right side. Expand the menu for SCADA HMI application. Here you will find the three types of SCADA PC stations. For server station, add WinCC RT Professional, and for client and engineering station, add WinCC Client to this project. Now select and add the WinCC RT Professional in this project as server station. WinCC Runtime Professional is added in this project that has been appeared as PC Station 1 in the project tree. This PC station will be referred to as Server PC Station. There have some settings for this PC station that now have to be done for this PC station to be configured as WinCC Server Station. On the Hardware Catalog, expand the tab for Communication Modules. From the Profinet Ethernet, select IE General and drag and drop this module to the slot of the PC station. On the left side, locate the cursor to PC System 1 and rename this PC station as Server. On the Device Configuration window, select the Server PC station and go to the option for General Settings under the Properties tab. Put the tick mark in the empty box for Computer Name identical to PC Station Name. Now select the Communication module, IE General. Under the General tab, go to the option for Ethernet Address. Click on the button for Add New Subnet to assign a network for this PC station. Then go to option for IP address setting and put the IP address as 192.168.0.2 that we have decided to be assigned for the server PC. After server station, proceed to add the client station. From the project tree, go to the window for Add New Device. Move to SCADA HMI application and add the device WinCC Client in this project as Client PC Station. Like the server station, add the communication module IE General to one slot of Client PC Station. Rename the PC station PC System 1 as Client. In the Network Settings options, add the same subnet that has been selected in the case of server station. Scroll down to the option for IP address setting and write IP address for client station. Select the SCADA PC station and move to the option for PC General Settings. Put tick mark in the checkbox for computer name identical to PC station name. Now in the project tree, scroll up to Add New Device and double-click on it. From the window for Add New Device, add the device WinCC Client in this project. This will be referred to as Engineering Station in this project. From the hardware catalog, add the Ethernet module IE General to the slot of Engineering PC Station. In the project tree, move to the PC System 1 and rename this device as Engineering Station. In the general setting for this station, put the tick mark in the checkbox for computer name identical to PC station name. Select the communication module of this PC station. Under the Properties tab, go to the option for Network Interface Setting. Add the subnet for this station, like the subnet for server or client station. Scroll down to the options IP Setting and write down the IP address for this station.
The PC station for engineering, server, and client have been added and configured in this project. Now we are in the Hardware Configuration window under the Device View tab. Switch to the tab for Network View. Here you will find all the devices that have been added in this project. As each PC stations was assigned to same subnet during hardware configuration, all PC stations are now found to be connected in a network in this window. To add the S7-1200 PLC to this network, make a network connection for this PLC with PC stations. Now all devices of this project have been registered into the same network. Now make HMI connection for the engineering, server, and client PC station. Click on the icon for Show Address Labels. This will show addresses for the devices connected in the network. The IP address for these PC stations should be matched with the IP addresses that have been configured from the IPv4 settings window of 3 computers. Also check whether the PLC IP address configured in this project is matched with the actual PLC IP address.
One more issue, you have to check whether each PC station has the correct driver configuration in the PG/PC interface setting. This means selecting which communication protocol and network adapter card a PC station will use for communicating with other devices. So for data exchange with each other, you have to adjust PG/PC interface settings perfectly for each of the PC stations connected in the server-client network. Go to the PC for server station. Using the search bar, open the window for Control Panel. In the search box of top right corner, type PG/PC interface. On the left, you will find the tab for PG/PC interface. Click on this to open the dialog box for PG/PC interface. Dialog box for Set PG/PC interface has been opened. Using this dialog box, you have to select the communication protocol and network interface card
that the PC will use to communicate with PLC or other PC station. In this PG/PC window, S7 Online has been selected for Access Point of Application. For interface parameter assignment, you have to select the network interface card that the PC is using to communicate with other PC station or the PLC in the network. For this server PC, the Ethernet card is Realtek PCIe GBE family controller, and the communication protocol is TCP/IP. So interface parameter assignment has been selected as Realtek PCIe GBE family controller .tcp/ip.auto.1. Click on the OK button to close this window and go back to TIA Portal project. In the same way, adjust the PG/PC interface settings for engineering and client PC station.
Now we are going to create an HMI interface for our project. In the Project Tree window, go to Device for Server Station and add a blank screen under the tab for HMI RT1. A blank screen has been appeared on the right side. In this blank screen, a graphical user interface will be designed and configured using a number of symbols that is provided in a toolbox on the right side. Finally, this is the HMI interface from which motor operation will be done. Here, On button is configured with the ladder address M10.0, Off button configured with M10.1. For motor indication, a circle has been configured with the ladder address Q0.0. To show the motor runtime, a numeric field has been configured with memory address MD20. Now to perform an operation from the client or engineering station, you have to log in runtime project using a specific ID and password. So a number of user ID with password have to be created from the tab for user administration. In the project tree, navigate and open the window for user administration. Here under the Users menu, you can create a number of users, each of which must have a specific ID, name, and password. The users that will be created must be assigned under a specific group. As the operation will be done from both client and engineering PC, we will create two users with specific name and password. Note that the server station requires no user ID or password to log in to runtime WinCC project. Two users with specific ID and password have been created. Note that, by default, these users have been assigned to the group name Users under the list for Group.
Now go to tab for User Groups in this window. Click on the group which name is Users. In the bottom, you can define the authorization level for this group to control their access to the function and data in Runtime Project. When user will log into the Runtime Project from Client or Engineering Station, they will get the permission for activities that have been selected from the list under the tab for Authorization. You can customize these selections depending on your application. Now close this window and proceed to move for next step. Creating WinCC project has been almost done. Now what we have to do next is transfer the WinCC project to the server PC. This project will be transferred as runtime file in a specified folder in server PC. For that, we have to create a folder in the server PC and share this folder so that this will be accessible from other PC stations connected in the network. Go to PC for Server Station. Create a folder and provide a specific name for this folder. This folder will contain the runtime project file. To access the runtime project file from any client PC, this folder has to be shared in the network. For folder sharing, go to Window for Network Access. From the drop-down menu, select Everyone and click to add this to the list for Windows user. From the option for permission label, select Read/Write from the drop-down list. Click on the Done button to close this window. Now the folder is shared with Client and Engineering PC Station. Go back to WinCC project. We are now on the Engineering PC Station where WinCC project have been created. To transfer the project, first select the device for Server Station in Project Tree window. Go to the drop-down menu for Online and select the menu for Download to File System. Select the tab for Network to find the server PC in the network. Click on the PC for Server Station. Select the folder where the server project will be transferred. Click on the OK button. Click Load button to proceed for transferring. The runtime project file has been transferred to the server station. To check whether the server project has been transferred to Server PC, go for Server PC. Click to open the shared folder to find the project runtime file. Here is the runtime project file in the Server PC that has been transferred from the Engineering PC. Finally, we have come to the runtime file for WinCC project, which be run on the server station.
Go back to WinCC project on the engineering station. We have come to finish all necessary PC configurations as well as creating the schematic WinCC project on the engineering station. Now it's the time to run WinCC project on the server station and perform motor operation from the server, client, and engineering station. The PC stations must be logged in using the same Windows username and password when you power on these computers. So we can proceed first by starting the runtime project on the server station. Restart the server PC and log in to PC Windows. Open the software component WinCC Runtime Start. Browse and select to load the runtime project file on the WinCC Runtime Start.
Click on the Run button to activate the runtime project file. Runtime for WinCC project has been started. Perform motor operation from the HMI interface. Observe, as WinCC project is running now on the server station, we are able to perform motor operation and monitoring activities from the HMI interface of server station. To perform the motor operation from the client station, restart the client PC and log in to client PC using same ID name and password. Open the software tool WinCC Runtime Start. Browse and select the runtime project file that is located in the server PC. Provide the user ID and password that has been created in the WinCC project. From the client station, process is going to access to the runtime project that is already activated and is now running on the server station. Perform motor operation from the client station. In the same way, restart and log in to the engineering station. Open WinCC Runtime Start. Browse and select the project file that is located in the server station. Provide the username and password to log in to the WinCC server project. Engineering Station is now in the process of connecting with the runtime project of the server station. Perform motor operation from the engineering station
Let's come to know what will happen when the runtime project is deactivated from the server station. Deactivate the runtime project from the server station. Note that as the runtime project is deactivated on the server station, we are not able to perform motor operation from both the client and engineering station. Now load and activate again the server project on the server station. Connection for client and engineering station has been established with the server station, and now we are able to perform SCADA operation from both the client and engineering station. We have reached almost at the end of this video. I think this video will be helpful for you to get an idea about WinCC server client system and shows the way how you can develop WinCC SCADA system with server client architecture. If you find this video helpful for you, please like, share, and make comments on this video. And don't forget to subscribe this channel.